So here I'm going to talk about large language models for code generation. My name is Baptiste, and I'm a research scientist at Mistral since 3 weeks ago. Before that, I was at Meta, working on things like Code Llama and Llama 3, and now I'm working more on the code scroll models. So first, why would you want to build models for code generation? I think something that I need to say less and less over the years. But there are a lot of developers in the world, more than 28 million. And it turns out that developers actually want to use Gen AI tools. So according to this survey from Stack Overflow from last year, about 3/4 of developers are already using or want to use AI tools to help them to become more efficient. And as you can see, they cite reasons like increased productivity, to speed up their learning or to reach greater efficiency. And then for code generation, it's a domain that has been around for quite a long time. As far as in 2016, some people were already using methods based on deep learning to do code synthesis or other things to build some tools for code models. And there was really a renewed interest in Gen AI for code with Codex, which is a model that was behind Copilot in 2021. And you can do quite a lot of tasks with Gen AI, things like code completion, program synthesis from input-output pairs or just from a prompt, code reviews, code explanation, refactoring, and many others. When it comes to existing models to do that, I like to group them in 2 categories. So some of them are closed models, like Gemini, the family of models from Google, the models from OpenAI or the model from Anthropic. It will be the most famous ones. And basically, these models will run in the cloud. You cannot get the weights yourself. You cannot run them locally or fine-tune them. Well, for open models, like those from Mistral or Meta, for instance, you can fine-tune them for your particular use case or for your particular code base. And you can also run them locally without internet connection. That's something you can actually do very easily with tools such as Ollama. And these models also benefit automatically from community improvement. So when we release Code Llama, just a week later, even less than a week, a few days later, some people had already quantized the model and put it in a tool that's very simple to use in order to run the model locally on a laptop. And they're also free to use, at least if you want to use them for research and non-commercial purposes. Like here, this slide is a very small primer about LLMs and how they work. So basically, LLMs are based on predicting the next word, based on all the previous words coming in your sentence. And it's something that you do for all your tokens and for a lot of text. Probably know that LLMs are trained on big amount of data. So generally, it will be in the trillions of tokens. So for this sentence here, for instance, the cat sat on the mat, you will basically predict all the words like that with a method that's called teacher forcing. You predict all of them at the same time when training. And when doing inference, you can just generate these words one by one. So basically, given the beginning of the sentence, you ask the model to generate the next word and then the next, etc. And the architecture that is mostly used for LLMs is basic transformers, which is pretty simple architecture. Basically, you have each layer is composed of self-attention and FFNs with some normalization in between. the main thing to notice is that the self-attention scales quadratically with the size of your input. So if you have big inputs to give to your self-attention, it's going to cost a lot. And well, it's linear for the FFM. But yeah, it's a very simple layer, and just by stacking them and training with teacher forcing and backpropagation, you can actually get pretty impressive results. So, for instance, you can build some tools to do autocompletion in your IDE. So here, using one of these tools, if you just type def merge sort, the algorithm is going to understand that you want to implement merge sort and actually do the implementation. For other use cases, such as chatbot use cases, where you want to actually ask a question and get the answer for any of your questions, you need to do a little bit more. You need to also do instruction fine-tuning, and something I'm going to talk about later. But here you can see an example of what you can do with that. So here, I don't know if you can all read, but you basically we're asking to list all the text files in the current directory, excluding the subdirectories that have been modified in the last month in Bash. And yeah, here, fair enough, the model generates an answer, generates the actual command that you can copy-paste to get your answer right away. And it will also explain how it works so that you can understand the find command better. And it's something that can be pretty useful because it can save some time. So here, for instance, maybe it will have taken you some time to look at the documentation of find to find out exactly what you need to do. And in this other case, it's also the same. So here it's an example where for the CodeLlama paper, we actually use the model itself to generate one of the figures. So basically, the details are not that important here, but basically wanted to get some correlation heat maps between the performance that we get for different languages. And there are a few things that are a bit special. So for instance, we want to mask the upper triangle in the correlation heat map because it will be symmetric anyways. And even for computing the correlations, apparently you need to call core in pandas. But if you're not really used to this kind of workflows, it's something that you will probably have need to look up online. Well, here you can just ask this question and you get the result right away in just a few seconds. So here is the figure 3 from the CodeLlama paper, which was generated with this command. So for the first application I was talking about, to generate some, to complete some code in the IDE, you really need to do this thing which is called fill in the middle, also sometimes called theme. And basically the idea here is that no one writes code linearly starting from the top of the file and finishing at the end of the file. Generally, you always go back and forth from in several parts of the file, and you want to be able to generate some code using the context that comes before and after the cursor. So here in this example, you first create a main in which you define a character called Alice with 45 and a software engineer. And then if you just press class, if you just type class at the top, the model is going to understand from the context before and after that it needs to actually generate the actual implementation of this class. And it also infers that the first attribute is a name, the second one is the age, and the third one is job. So to go into a bit more details about how a theme is done. So basically, you just reorder the examples. There are two ways to do it, either suffix, prefix, middle, or SPM, or prefix, suffix, middle, or PSM. And the idea is that you want to have the middle in the end because it's what you want to generate. And afterwards, it will allow you to just generate from left to right. and to generate the middle this way. Generally, we tend to do suffix, prefix, middle because it performs slightly better since you have the prefix right before the middle, which is more natural for the language model. And once you reorder like that, just train normally like you will do, one of the first slides that I've shown in this presentation. And at inference time, you just format your suffix and prefix exactly in the same way. And actually, when you do PSM, when you do SPM, you can even drop the middle marker because if you already have the suffix and the prefix here, it doesn't really make any difference because the middle could just be a continuation of your prefix. So in the example that we had before, here it will be, so you will put the suffix on top if you do SPM. So the definition of the character Alice. And then you typed class. This is a prefix. And the middle will be the implementation of the class. So at training time, you train on this entire thing. And at inference time, you just give suffix and prefix, and your model is able to generate the middle.
Yeah, sorry. So what if in this example, you had functions that were imported from another side? Would you include them in your suffix, or you would just ignore the other part?
Yeah. Okay, the question is that what if you have some functions that are imported from another file? What do you do in that case? Do you include them in the suffix or prefix? And so there are several ways to do it. The main way is to include them in the prefix. Generally, if you include everything that is imported in your file, the context can grow quite a lot. So it can affect your performance, and sometimes it's going to go out of your context window. But generally, it can be good to include these kind of things, and they will go in the prefix. And also, some people just including a summary of everything that was imported, like just the signature of the function, for instance. Then to create a chatbot, what you need to do is instruction fine-tuning. So here the idea is that you will just train your model to follow instructions and to actually answer instead of just completing code. So the idea here is that you will train your model to generate this kind of sequences here with a prompt that is between some special tokens. So here it's inst and /inst or \inst. But it could be any kind of special token, really. And then after that, you try to generate the ground truth solution, which is here this function to compute if a number is a prime number or not. The main thing that is different here from normal pre-training is that when you're looking at the prompt, you're not adding a loss for predicting all the tokens of your prompt, only for the tokens of the answer. Then it's pretty costly to get some fine-tuning data for code, especially because programmer time is pretty expensive. And here this function is very simple, so maybe a programmer will be able to implement it in just a few minutes. But for a lot of prompts, it will actually be much more complicated, and it would be very expensive to pay people to generate all these examples. So something that you can do instead is that you can get your model to generate an answer and then only ask people for preferences or only ask them to correct the answer generated by the model. So here in this example, for instance, you can see that the only difference is that here we stop at the square root of the number, which is more efficient than stopping at number -1. so the solution on top is better than the one on the bottom. And it's generally easier it is generally easier to compare two solutions and to select the best one than to generate a solution from scratch. And another thing you can do, because you're working with code, is that you can just run the code. And here, if you have some unit tests to check the correctness of this function, you can check that both of them are correct and that the first one is much more computationally efficient than the second one, meaning that it's the one that should be preferred if you train with RLHF. Okay, so then I'm going to also show you some metrics to evaluate models for code generation. And here, this is an example from Human Eval, which is pretty classical benchmark for code generation. So the idea in Human Eval is that you mostly get very simple self-contained functions. And the prompt that you're given is the signature of the function. So here, it's called unique, and it takes a list as argument. And also a docstring that tells you what the function actually does. So here it returns a sorted unique elements, the sorted unique elements from this list. Also with an example of of application of this function. And what you need to generate is the part that is highlighted on the bottom, which is the actual implementation of this function. Here it's a single line, but it could be much longer than that. So here, with a benchmark like that is average on several programming languages. So the first thing that you can see is that, like here, the model size is on the x-axis. So if you go more towards the right, it's larger models that are more expensive to run. And the y-axis is the average score. So higher is basically models that perform better. The first thing that you can see is that like the models that tend to be more on the left and toward and higher are Llama 3.18b, Codestral, which is a 22 billion parameters model, and Mistral Large 2, which is a model with 123 billion parameters. So those seem to be the models that perform the best for their size, at least among open models. So GPT-4o here, I set it on this graph as having the same size as Llama 3.1405b, but the size of GPT-4o is not actually public. But as you can see, it performs only very slightly better to Mistral Large 2, and a bit better to Llama 3.1405b, and Mistral Large 2 performs better than the largest version of Llama 3.1, even though it is several times smaller. So if we look at some other benchmarks, so here it's Codestral compared to other models that came out at that time. So you can see that the context length is larger than for other models such as DeepSeek Coder or Llama 370b. And it also tends to perform similarly or even better on most benchmarks, even though it is much smaller. It has only 22 billion parameters compared to 70 billion for Llama 3. So this is the value that I was showing in the graph before. And the others are, Spider is especially for SQL. And Human Eval and MBPP are mostly for Python code generation. I also have a video to show you. Yeah. So I want to leave you with an example of something that this type of models can do. So here it's in a chat mode, and this version was using CodeLlama 34b, which is actually a pretty old model for code generation. And here we have the model to write a simple version of Pong using Pygame. which is a pretty complicated task because first you need to understand what it is about, understand what Pong is, and then you also need to make some design choices such as choosing which keys to use to move the pedals, how fast the ball should move, and things like that. And then, of course, you also need to actually implement the code and have something that will execute and give you this game. So here the model says, yes, sure, I'll do that. Start generating the code. And if you run it afterwards, you can already start playing the game. Okay, so here on this last slide, I want to give you some pointers on how to try CodeStral, which is a very good model for its size. So especially if you want to run something that does completion in an IDE, I think it's very appropriate. Mistral Large, the last one, is actually better if you want to use it in chat mode. So first, the weights are available on Hugging Face. So you can download it, fine-tune it, run it locally using Hugging Face. And it has both instruct and fill in the middle endpoints if you want to use our API to get some completions from CodeStral. There is also an integration in VS Code or in JetBrains using Continue. And here you can find a link helping you to set up Continue with CodeStral. And it's also it's also free to use with Le Chat, and Mistral Large 2 is also free to use in Le Chat, which is the version of ChatGPT that we have at Mistral. And yeah, you can also access it on Lab platform through the API. So thank you very much, and don't hesitate if you have any questions. Yes.
Like general question, what are the best techniques to make a RAG chain with code generating LLM? And more specifically, is it possible to like have a loop with static analysis of the code that is generated if the code is not working?
So did you say RAG chain, like in
yes, like
retrieval augmented? Yeah, so I think that all the plugins for IDEs out there do some kind of RAG, or most of them at least. So for the best way to do it, I wouldn't really be able to say because there are a lot of methods. For instance, I know that people often use the other files that are already open in the IDE, or files that are in like in the same folder. You can also do actual retrieval by computing some representations of different snippets of code and retrieving the ones that seem to be the most relevant in this case. And you can also use the imports as we were discussing before. But the best method is takes a lot of trial and error, and generally it's something that's a mix of all of those. And then, sorry, what was your other question? Does that answer your question?
The other question was about static analysis tools.
Yeah, I think that's also something that you can do. So typically it's something that's done more in, so for code completion, you want to answer very fast. So generally you don't have time to sample several answers from the model and to select the best one after doing static analysis. It will create a frustrating experience for the user because you will wait for too long before being able to complete. But that's something that's definitely done in tools that are more in chat mode. I think they do it also in GitHub Workspace, where basically you can ask the model to do anything in your repository, and it will spin up some kind of agent that will modify your code and do some analysis afterwards to see if the modification is correct or not.
You've shown a plot where you compare the performance of different LLM. How do you evaluate them? And what kind of performance do you evaluate?
Yeah, so here on this plot, it was on a multilingual version of human-eval and average over several languages. So yeah, basically it was this thing that I was showing there. So you train to, you evaluate the capacity of the model to generate the actual implementation of the function, and then you evaluate using unit tests. So for each of these examples in the benchmark, you also have some unit tests checking that the implementation is correct. And just by running them, you compute a metric called the pass at one. One for you want the single generation that you give to be correct. And pass because you measure the correctness by checking that all the unit tests pass with this generation.
Previously, you talked about filling the middle during training time, and if during inference time, if you don't have these specific tokens for filling the middle, is it a specific trick to have this fill in the middle just to prompt chain, something like that?
Yeah, so you need to have these tokens at inference time. The thing is that so basically you will select some middles randomly at training time and generate the tokens this way. At inference time, the API will look like something where the user will give you a prefix and a suffix, and you want to generate the middle. So on this example I was showing before, so here, the suffix will be the main here, which where you define the character Alice, and then when the user types class character, the caret is there, the cursor is there, and you will consider that everything that comes before the cursor is the prefix, everything that comes after the cursor is the suffix, and then you can reorder this way and add the special tokens.
Okay, so my question is, what are the differences between Mistral and meta models? Like the biggest differences? Is it prompting? Is it architecture, data?
Oh, you mean what is the difference? Like why are some better than the others? Or?
Yeah, not just for the user, but also, yes, for the user, but mostly for the design of these models. Like are they like copies or what?
Yeah, so I think the architectures are pretty similar, and they're also pretty similar to those used by others. Generally, it's mostly transformer networks. But I think there are a few, there are more types of models that were released by Mistral. For instance, there is Code Mamba, which is a version of Cotral that is smaller and based on the Mamba SSM architecture. So that's a different architecture, and for instance, it's only linear in the context length, so it can bring some benefits in some cases. Otherwise, there are some MOE models that were released by Mistral and none were released by Meta. So MOE is a mixture of experts, meaning that only some of the parameters of your model will be used for at each time. So it's something that can allow you to be more efficient in some cases, because basically you can have a larger model, but that doesn't require that much compute to train or at inference, because most of the parameters are not used most of the time. And yeah, otherwise in terms of, I think very big difference as well is in terms of model sizes. So for instance, CodeStral is a 22B model, and none of the Llama or CodeLlama models are coming in this size. It's going directly from 13 to 34.
What about
and
the context
Yeah, for the context size, well, the new Llama models and the new Mistral models both have pretty long context, but the long context fine-tuning is done a bit differently. Like Mistral, since the beginning, uses windowed attention. Well, that's not really the case at Meta. Yeah, I would say that for long context fine-tuning, the capacities of the models are pretty similar for the last ones.
Yeah. So based on both your experiences in Meta and Mistral, are there like main differences in dataset preparation for the pre-training of the models, or are there like universal guidelines that were followed both in Meta and Mistral?
Yeah, to be honest, I think that the data preparation is done better at Mistral, and it's one of the reasons why the models are generally better with less compute resources.
Talking about data preparation, is there any main guidelines to which code you select to train this kind of model? You were saying for the if I am you choose the middle randomly in the code. What do you do if you have like a code where you have not much coherence between the several parts of the file? You choose the middle, but it does not relate to the other parts. Is there any guidelines to select code that makes sense and which will do good training?
Yeah, so for filling the middle, selecting snippets randomly seems to work quite well. At least if you train for long enough. So basically, if you train on trillions of tokens with theme, selecting randomly is going to be very robust, and generally what people do. Something I can say is that so there are two ways to do fill in the middle, to select the middle. It's, you can do it by selecting the middle based on the number of tokens, or you can just cut randomly at any character. And it's definitely much more robust if you cut on any character, because like otherwise you basically wouldn't be able to do theme if the user wants a completion that starts in the middle of a token. That makes sense.
Thank you.